my name is Dave Saalfeld. I'm a research biologist with the Alaska Department of Fish and Game. And technically right now I'm the fur bearer biologist for our region too. And most of my projects focus on lynx, wolves, wolverine. However, this project on moose here is a carryover from my previous position with the department. And before I really jump into this, the background and results from this study, I really want to thank all the members of the public who participated and called in moose sightings, because without them participating in this unique project, there's no way we could have been successful getting the data we got. And along with myself, there was 3 other biologists, Dave Battle, Corey Stantorf, and Sean Farley, who were instrumental in pulling this project off and getting this off the ground. So first, let me go into a little background about moose in Anchorage and the larger game management unit, which is 14C. Effective management of any moose population requires good population data. Anything from survival rates to mortality rates, population estimates, all help a biologist manage the moose population. However, very little is known about moose in the Anchorage and the overall game management unit 14C. And for those of you who are not kind of familiar with how Alaska is set up with game management units, Anchorage falls within game management unit 14C, and it basically runs from the Knik down to the 20-mile placer drainages. This unit also falls under the intensive management law. So this area actually has population objectives and harvest objectives that biologists try to meet. And the population objectives are between 15 and 1,800 moose in the area, and a harvest objective of 90 to 270 moose. And that's for the whole game management unit. Overall, a large percentage of the winter moose habitat actually falls within the Anchorage Bowl. If you think about the Anchorage area, a lot of the good moose habitat higher up in Chugach State Park is steeper elevation, and winter snow oftentimes pushes moose down lower elevations. So you see a lot of the better moose habitat for wintering areas falls within Anchorage area and Jay-Bear. So why study moose in Anchorage? There's always been safety concerns. We get numerous calls throughout the year, particularly in the spring when moose calving season is going on. There's a lot of negative interactions between bikers and moose, and Dave and Corey, the area biologists and assistant area biologists, get lots of calls about concerns about moose and nuisance wildlife. There has been proposed hunts in the area before. A couple board of game cycles ago, there was a proposed hunt for Kincaid Park. There's likely lower natural mortality in the Anchorage area. So this is a unique area to study since there are less wolves or bears that can really impact moose survival rates. The low cost study. So most studies on moose involve aerial surveys or aerial work. And having Anchorage in its extensive road system, we could save a lot of money to conduct a study here. It's a dense moose population within a small area, which allows us to have a high likelihood of recapturing individuals. And during a survey, there's very limited movement in and out of the area. So how do we traditionally survey moose? We typically find most of our moose surveys when there's good snow cover. If you look at the picture here on the right, you can see how there's almost complete snow coverage there, and you can really pick out a moose from the surrounding vegetation. And we do most of our surveys through the air with fixed wing aircraft or helicopters. And we usually conduct 2 different kinds of surveys, sometimes called a composition survey, where we're trying to figure out how many moose or bulls and cows and calves are out there. Or we could be conducting a population census where we're flying around and trying to estimate how many moose are out there. One of the difficulties with doing a traditional aerial survey in the Anchorage area, particularly the Anchorage Bowl, is the Class C airspace at the international airport. Typical moose surveys, when you're flying low above the trees and trying to count moose, you'd be pulled out of that area from the Class C airspace. We oftentimes fly a lot of tight transects really low, and Anchorage residents would not be very happy with us buzzing over their houses when we were trying to count moose. So that was one of the reasons why we could not fly a true aerial survey. And another issue has been a lack of early snow in our area. Typically by late February, we have plenty of snow to conduct a good moose survey. However, we've noted that a lot of the moose move from the higher elevations down into the thick brush, and it makes conducting a good aerial survey difficult. Because of these issues, we came up with this new methodology to estimate moose in Anchorage using a genetic-based biopsy sampling. So these biological samples enable us to obtain an annual minimum count. So just to break what that down is basically we know there's at least this many moose in Anchorage. And as we conduct multiple surveys over several years, we're able to come up with a population estimate using what's called mark recapture. And I won't go into a lot of detail about statistics. I'm going to kind of gloss over this and just focus more on the results from the study. In addition to getting population estimates, this survey could also provide good data on sex ratios, survival rates, susceptibility to harvest and roadkill, and movement and dispersal rates. So how to effectively locate moose in Anchorage? And it's a really difficult question. We spent a lot of time thinking this through. We could spend a lot of time driving up and down roads and hiking trails, but the difficult thing about Anchorage is finding all the moose that are in people's backyards. So what we came up with was to make this more of a citizen science-based project and then enlist the public's help. And it was a fantastic project overall. We had a lot of support from the public. So what we did was we conducted a really extensive public relations campaign where we put out press releases, social media posts, did a lot of interviews. In this project, these interviews got picked up from the lower 48 all the way to international news agencies picked up the story. So it actually was a pretty popular story and really unique because not many people try to get the public to help out with a large scale project like this. And when we actually conducted the survey, we had the public either text us, call us, or report online any moose sightings. So the objectives were to estimate, like I mentioned, the population size, sex ratio, survival rates using DNA-based mark recapture. And overall, we're just testing a new methodology to see if we could actually come up with good population estimates with this technique and without snow cover. And some of our secondary questions focus more on relatedness and paternity within the moose population in Anchorage and movements between years when we sample the same moose over and over. So this gives you an idea of the study area for where we conducted this survey. So overall, the study area was approximately 85 miles squared. But when you really look at the map, you can see a lot of that's developed area, and a lot of it's not accessible to moose. And when you think about the international airport, a lot of that's high fence, and so that large chunk of land there is really not even available for moose. So even though the study area is overall is 85 miles squared, it's a lot smaller when you think about the available habitat for moose in Anchorage. And it's going to give you a perspective. The overall game management unit is about 1,900 miles squared. So Anchorage is a small percentage of the overall game management unit. So there's two main phases to this project. We had the field-based sample collection, and you can see one of our biologists there. What we did was we roved around with teams, and we shot what's called a biopsy dart. And this dart lightly hit a moose. It collected a small piece of tissue, and then that dart would fall out, and we would recover that sample. And with all these samples, then we had to take all this stuff back and take it to the lab. And we used two different labs. We used the gene conservation lab with Fish and Game, and we also used the USGS molecular ecology lab to help us analyze these samples. And I'll go into a little bit more about what these labs did here in a little bit. So how did we sample and cover this whole area? So we recruited a lot of staff and volunteers. Even though the survey was only for 3 days, we had 7 to 8 teams out there in the field of 2 to 3 people, and they were driving around and hiking and covering as much of Anchorage as possible and responding to all the moose that the public were reporting. And what I ended up being the person running was the office-based crew where we staffed the phones and we provided real-time mapping of all the moose locations that were being called in by the public. And what was really unique and really helpful was we were able to post these onto iPads, so teams could actually navigate to each moose sighting, just following the maps in an iPad. And with Anchorage still having a lot of green space, we had to have dedicated teams to canvass these green spaces to make sure we covered the whole sample at study area. So for field work, this map on the right kind of gives you how we broke up Anchorage. And we had 6 to 7 teams, and we basically had these little polygons to keep teams from having to travel too far across the city to find each moose. So we basically had 6 teams that were covered each of these polygons here in this map. And then we had 2 to 3 teams of green space teams that were hiking the larger green spaces like Bicentennial and Kincaid and some of the other larger parks, where it would be too hard for the teams driving around to spend a lot of time in those areas. Since Anchorage have a high density of people, we had to make sure that we had at least an experienced biologist who's used to navigating, working around Anchorage on each team. And as they were traveling around, we made sure we recorded all the locations of all darted moose, and all tracks and stuff were recorded on the GPS unit to kind of show how much we hiked and drove around each day. And this is just a couple of maps just kind of show you what the iPad unit would look like for our teams. This first one here on the left is what the iPad unit would look like. So in real time, as the public were calling in reports, I would be punching these into what's called ArcGIS Online. And then I was able to submit these locations right to an iPad unit. So the team would have, every time a call would come in, the team would always have that location in real time. So those black dots are moose reported by the public. And they're able to use the iPad and then navigate the streets of Anchorage and find each of the moose that were being reported. A couple of things we learned while we were out and about doing this kind of stuff. Darts were sometimes really hard to find in the snow. So we ended up having a green space team that helped us recover darts. So they'd come around with a metal detector and come back to close to where the team thought the dart fell out in the snow, and they scan around till they find it. Another thing we learned was a lot of the times, since the dart hit the moose so lightly, that the moose would not move off. And so we'd have to have the team that darted would wait around 10, 15 minutes, but there was a lot of other moose for them to go try to get samples from. So we had a backup team that come back in and try to recover those darts when the moose would finally walk off and leave the area. And one special note, we kind of had to revamp everything. So we started this project in 2017, and that was a pilot year where we didn't really conduct a full survey. We wanted to kind of test out this methodology to see if it actually worked for us. And then 2018 through 2020, we were able to conduct a full survey, and everything went really well. We kind of had to reinvent the project in 2021 to kind of take into account with COVID. It was really great that basically a lot of our experienced staff had their family members help them out. So we had basically family group teams last year. And with the higher number of people basically hanging around Anchorage and being on the trails that year, we actually had the most number of reports from the public that year. And we had over 1,000 reports that year, just over a 3-day period. So for genetic analysis, just real quick, the bottom picture here shows you basically what the biopsy dart looks like. You can see they have a small cutting surface on the front there. That's the part that's kind of pulled off of the dart there. And then you see a little long wire looking barb. So that cutting surface barely strikes the moose, takes a small piece of tissue with it, and those barbs inside hold it in there. So when the dart falls out, we're able to keep the sample inside the dart and recover it later. And so when we get that piece of tissue, we're able to use the DNA from that to identify individual moose. And then in addition to collecting the biopsy samples during that 3-day survey each year in February, we also collected tissue samples from Roadkill and Hunter Harvest. And like I mentioned earlier, this is a big collaboration with the Fish and Game Gene Conservation Lab, who ran all our samples, and also the USGS Molecular Ecology Lab. So just for results, so like I mentioned, 2017 was a pilot year, so I really won't be reporting much about what happened in 2017. But from 2018 to 2021, public participation was overwhelming. Each year we averaged over 800 reports over a 3-day period. In some years, like I mentioned, in 2021, we had over 1,000 reports that year. So a lot of public participation and made it a huge success for this project. And over that time, most everybody preferred reporting online or texting. Very few people wanted to call in. So about 75% of our reports were from texting and online reporting. And during the survey, teams were able to interact with hundreds of residents while sampling moose, which was great for public relations with our department. So here's some just breakdown, some stats of basically everything we did when we were out there. So on average, teams drove about 1,800 miles per year driving around Anchorage. So we covered a lot of ground when we were out there. The green space teams hiked over 200 miles per year. At minimum, to pull this survey off, we needed 16 staff and volunteers per day. And on average, we had basically 45 different volunteers and staff participated each year. So a lot of staff and a lot of volunteers. And it basically was a real intensive 3-day period, over 700 hours of work for that 3-day period. Like I mentioned, this being a ground-based survey, it's very cost effective when you consider how much money would go into a traditional aerial survey. When you add helicopters or planes, the cost amplifies dramatically. So just getting into the locations of all the moose, this map here shows you basically every sample we got from 2018 to 2021. And you can see we had really good coverage across most of Anchorage. And one of the things we really noted was even though we had green space teams spending a lot of time hiking and covering a lot of ground, we had very few moose sampled in the larger green spaces like Bicentennial and Kincaid. And if you really look at the map, a lot of moose, a lot of samples on the edge of these green spaces, you can almost interpret this and looking at this, and it seems like a lot of moose like to spend a lot of their time outside the green spaces, probably more in the neighborhoods in the wintertime, probably because of the amount of ornamentals in Anchorage. In these green spaces, there's not as many trails or plowed roads. So, neighborhoods provide a lot easier movement for them. So even though we spent a lot of time sampling these green spaces, we feel like we got good coverage overall for all of Anchorage, and we covered the study area pretty well, trying to get as many moose as possible. And this is just a quick graph of our minimum numbers of moose we got each year. So the first year was our lowest year. We had 139 moose, unique moose. And then the next 3 years, 2019 through 2021, was pretty consistent. We had 178 in 2019, 172 in 2020, and 185 in 2020-21. You can see that adult cows made up the largest proportion of sampled moose. Jumping into this is our recapture rates. And so just to get a little explanation, basically, this is a number of animals that we captured in one of the previous years. So basically, the numbers from 2019, so 56 moose, we basically recaptured 56 moose that were originally sampled in 2018. So that gives us a 44% recapture rate. So overall, we had on average a 60% recapture rate, so a huge recapture rate each year. So we captured the same moose several years in a row. And basically in 2019, we had 56 recaptures, 2020, 94, and 84 recaptured in 2021. So very successful catching and recapturing animals from year to year. And so once we had these genetic samples, like I mentioned, we took these to we started off working with the USGS Molecular Ecology Lab, and they ran our 2018 to 2020 samples. And so they had 663 samples they ran. A lot of those, not all those are viable samples. Sometimes they're just hair. Sometimes we think they might have hit the moose and they did not hit the moose. So out of those 663 samples, if you think back at those minimum counts, we only had about 170 moose per year. So there's a lot of samples that were either non-unique moose, a moose was sampled more than once in a given year, or they were samples that weren't viable, that we didn't get good tissue to get DNA from. In 2021, we started working with the Gene Conservation Lab, and they ran our 2021 samples, all the roadkill and harvest samples we had. And then just to standardize between labs, they ran all our 2018 and 2020 samples. So they ran about 1,400 samples for us. One of our secondary questions was to start tackling paternity and relatedness, and we're kind of still working on that and waiting for some more results to tackle those questions. Just to look at, this is a map of how moose move between years. So we had 234 recapture events of 141 unique moose. If you really look at the map, moose really do not move much between years. I know this is a small snapshot when you really think about moose movements, because we only have one location basically a year. But in winter, it seems like moose really have site fidelity, and they do not move much between years. And you can see only a few of them really moved outside the study area. And we picked those up with roadkill sampling. You can see a couple of them down there along the Seward Highway to the south. And we picked those samples up with roadkill samples. And none of our marked moose in Anchorage actually turned up in any of the harvest records. So we had several show up in roadkill and other tissue samples we found for mortalities, but none showed up in harvest records. And just to give you a breakdown, like I mentioned, moose did not move much between years. On average, about 1.5 miles per year. And you can see the range was really small movements overall. I mean, some moose basically didn't move at all at 0.03 miles. And the furthest a moose moved between years was only 7.4 miles. Bulls moved on average just slightly more than cows, but you can see that their ranges were very overlapped pretty well. And bulls moved about on average 1.9 and cows about 1.4 miles between years. So for sex ratios, the mean sex ratio was basically 2 males for every one, 2 females, I'm sorry, for every 1 male. This is for our biopsy samples, which gives you basically, if you break it down, 67% female and 33% male. And for those of you that prefer that into a bull to cow ratio, that gives you basically 48 bulls per 100 cows. And if you look at just adults, it was adult moose sampled. We were 71% female with 40 bulls per 100 cows. And for calves, we are 56% female, which gets us a lot closer to an even sex ratio. And we had 78 bulls per 100 cows. And I mentioned calves, but in reality, these are February samples. When we conducted this survey every year in February. So these are basically 9-10-month-old individuals. So we missed a large portion of the calf survival period from May to February. So these are what some biologists call short yearlings now. So they're really close to a year old. So even though we classify them as calves, they are a lot older than basically what you see in this picture here. And for a cow to calf ratio, we found basically 38 calves per 100 cows. So we had a large number of calves per cow. And just to put that in perspective, these are some numbers from some of the aerial surveys conducted outside of Anchorage and some of the other drainages like Ship Creek and Eagle River and Eklutna. So in the larger GMU 14C, we found around 32 bulls per 100 cows. So we definitely have a higher bull to cow ratio here in Anchorage, and a higher calf to cow ratio too, where they found 26 calves per 100 cows. And these numbers are a lot more comparable than survival rate numbers, because these calf numbers for the GMU 14C were from flights that occurred in November, December. So we're talking comparing 8-month-old to 10-month-old calves. So a lot more comparable than we're talking young of the year calves. Just to kind of go into some of the roadkill and harvest samples. So we started collecting roadkill and harvest after the 2018 survey, so after February 2018. So during that period, we had over 493 samples we collected. And if you look at go back to the overall study area, we had 174 collected just within that study area. 28 were agency kills. And these are typically moose that were hit on the road that had such a severe injuries that biologists determined they weren't going to survive. So they were put down by an agency personnel. 3 were killed for defense of life and property. 101 of these roadkill samples were robust or hard kill samples from roadkill itself. 24 were natural mortalities, things like choke cherry kills, or I think that's most of them here, but David or Corey could be able to fill in more of those. They're the ones that collected most of these samples for us. 11 were harvested individuals, and this was from the hunts on jay bear. So our study area is right, part of our study area to the east is right along the jay bear border. And so some of those moose on that Muldoon jay bear side there were 11 moose that kind of fell within the study area there. And 7 of these samples were unknown causes of mortality. So within the study area, if you talk about these mortality samples we were getting, 40 of these were moose that we marked during the biopsy sampling. So 40 of these were what we call recaptures. They were 12 in 2018, 12 in 2019, 16 in 2020. And we really don't know how many we got in 2021 because we quit collecting samples after the February 2021 survey. So we did get a pretty good percentage of samples turning up in these that made it worthwhile collecting tissue sample from roadkill and harvested individuals. So now kind of jumping right into our population estimate. So I use some, basically I will kind of gloss over the statistics behind this, but basically we had samples from moose for 4 years. And basically based on the percentage of number of new moose and recapture moose, you can calculate how many moose are actually out there. And so on average, over the 4 years of the study, the average moose population in Anchorage is 310 moose. And with a confidence interval between 252 and 365 moose. And this is just based on the mark recapture data alone. We're not building in any of the roadkill or anything into this estimate. And you can see that the first year was a lot lower, and part of that's some of the math behind it. And so I would really focus kind of on the population estimates from 2019 through 2021. And you can see that they are pretty consistent. They basically hover around 300 moose. And this gives you basically a density of right around 3.6 moose per square mile. And if you really factored out a lot of the unusable habitat in Anchorage, factor out Ted Stevens and a lot of the really developed areas that moose really, you cannot find moose. This would give you a lot higher density if you could really dive in and get a smaller, appropriate study area for available habitat. Jumping into survival rate data. So this is kind of a byproduct of doing the mark recapture. You're able to calculate how many moose survive from year to year. In the mean survival rate for all moose in this study, it was 71%. And you can see it's pretty tight confidence intervals between 0.63 and 0.77. And again, when you break it down by age class, caution again that we're talking older calves. So we really don't know the survival rates from basically birth till February, which is really when they have a lot lower survival rate. So calves survival rate for this study was 0.52 or 52%, and adults were 78%. And you can see bulls had if you drop down to you break it down by sexes, they were very similar, but bulls had a slightly lower survival rate at 65% to cows 74%. And a lot of that probably is likely to the fact that bulls and young males are often considered the dispersing sex. And with moose breeding, their reproductive strategies, a lot of times the younger males are the ones that are going to be moving away from these areas to try to find their own harems to breed with. Overall, this is really a rough survival estimate. I will be talking a lot more rigorous one that accounts for the deaths and births, and this will be reported in future reports and publications. So overall, this project over these past 5 years provided a lot of valuable data and really helped us get a lot of good public relations with the people of Anchorage. We were able to get really good information on annual minimum counts, sex ratios. We're still hoping to get degree of relatedness. Hopefully that will be calculated soon. And so we got a lot of information on susceptibility to roadkill and hunter harvest. We got our population estimates and good information on survival rates, movements, and dispersal rates. So one of the things we wanted to really know is, can this survey, this technique really be used outside of Anchorage in somewhere where we don't have roads and good trails and good access? And what we found is we can likely probably apply this technique to some areas where there is limited movement of moose in and out of the system. And we're hoping to develop a study in the future to kind of test this technique in somewhere where we can't get traditional area surveys, like in maybe 20 mile. And that's typically just due to snow conditions. In the drainage down there where very few moose move in and out, we probably can accomplish very similar population estimates and get good numbers from down there applying this technique we developed. This study design promoted a really nice citizen science-based approach that was extremely valuable for our department and particularly good for public relations. So the composition of moose in Anchorage, we showed a higher bull cow and cow calf ratio than the surrounding area. There's a few things that could probably play into this. There's a lot less hunting pressure in Anchorage. Well, really, there's no hunting pressure actually in the Anchorage Bowl, but there is hunts in the surrounding area when you factor in the hunts on Jay Bear, the hunts up in Cable Creek, and then the hunts in McHugh Creek. However, no moose that we sampled in the Anchorage Bowl showed up in any of our harvest samples. And that, on average, in GMU 14C, we have about 124 moose harvested per year. We had a higher calf survival rate, but a similar adult survival rate to a study being conducted on the Kenai Peninsula. However, again, I'll just caution that it's not really comparing apples to apples with calf survival. Marked moose were detected in roadkill samples, but only about 10% of roadkill samples were moose that we actually marked during the study. So most roadkill samples were moose that we did not identify from biopsy samples. On average, in the greater GMU, there was about 91 roadkill samples of moose per year. And about 10% of those I mentioned were ones that we basically marked and sampled in Anchorage. Although a lot of our movement data is not really detailed as like a traditional telemetry study, you can really see some patterns from this data where you can see that moose really moved very little between years. Previous telemetry studies, this is a paper I'm actually working on right now. We had some collars on moose in Anchorage during the Elmore Road and a few of the other roads that were put in through that part of town. And so we collared some moose to kind of cow moose to see their movement patterns around town. And these studies showed that these collared moose really did not move out of Anchorage. We've always wondered is, we know that on Jay Bear, as snow conditions get deeper, hunters are more successful with harvest because moose seem to move into lower elevation areas, into more accessible areas for hunters as snow gets deeper. However, we weren't quite sure how many moose actually move into the Anchorage Bowl, and that's still a really big missing piece from the study. Is in winter, likely we have very little moose moving in and out of Anchorage, but during, I guess I should rephrase that. In fact, late February, after we have kind of our snowpack at a good level, we have very little moose moving in and out of Anchorage. However, we're not really sure how many moose move down from Upper Ship Creek or Jay Bear into Anchorage as winter progresses. We did document that a lot of moose were site faithful, and the collaring project did correspond with that. But we want to find out more, and this is something we want to investigate in the future, is figuring out how many moose do move and when they move to help us set up a better survey outside of Anchorage and when to conduct our aerial surveys. So overall, we estimated approximately 310 moose in Anchorage during winter. And density estimate is around 4 moose per square mile, and it's on the high side for Alaska. There's a few areas that have noted larger numbers than this, but it's really unknown if these numbers remain this high throughout the year. Like I was mentioning, we knew that those collared moose did stay around town, and they were resident moose, but we don't know how many additional moose might come into town during winter as snow levels get deeper. So I mentioned anecdotal evidence from JBER indicates moose density does increase within lower elevation areas during winter to avoid the deep snow. But we have no numbers that kind of quantify how many moose move down, and do they actually move into Anchorage Bowl, or do they stay on JBER and other areas of other lower elevation areas. Additionally, Anchorage Bowl is some of the best winter habitat within the GMU. And this is due to a lot of reasons. Basically, the abundance of browse, all these ornamental plants that people have planted around Anchorage really keep the moose, give them something that they can't get in other areas of the state. There's a lot of plowed roads. Even whenever there's deep snow anywhere else, they can come out to the roads, the sidewalks, the trails. It lets them have a lot more ease of movement through town. And this is something that makes Anchorage very unique, where anywhere else in the state, there's not this much basically easy corridors for them to move through. And like I mentioned, ornamental plants, that's one of the things that basically only Anchorage can provide for them. We're one of the really unique spots anywhere in the world where we have such a dense moose population with such a dense human population. I'm not sure there's anywhere else that has both of those together in the same area. So like I mentioned earlier, survival rates were slightly lower compared to a recent study of the Kenai, and this is something that was done by Thomas McDonough in the Kenai units. GMU 15A is basically everything north of Soldotna, and then 15C is everything north of between Tustamina and Homer, basically. And he's been studying moose populations down there for several years. And you can see basically, these are a couple of graphs from one of his presentations he recently did. And you can see his adult survival rates are a little higher than what we saw in Anchorage. But overall, they're very similar. And I wouldn't really probably say there's actually any difference between the two studies in survival rates for adults. However, we did see a higher calf survival rate. Like I mentioned, Thomas has been following them from May on, and we basically only know basically from February on. So we're missing a key portion of that survival data that we really can't say that our studies are comparable or not. There is a slight difference in survival rates between sexes, but it's likely due to males being the dispersing sex. So just to kind of wrap some of this stuff up, this project was a great way and a unique way for us to really get at moose numbers in Anchorage where we can't do a traditional aerial survey. And with us getting the public involved and do this citizen science-based approach, there was really no way we could have accomplished that without getting the public involved. And we really wanted to acknowledge and thank the public for the past 5 years for how much they participated, all their calls they reported for us. Without them, there was no way we would have been successful. Also like to really thank all the staff from multiple divisions. We had people from commercial fish, sport fish, habitat. We had people that we had the commissioner come out with us for a couple of days. We had staff from everywhere within Fish and Game help out with the survey. It was also a good way that we got our advisory committee members and volunteers involved. And we really want to thank all those that helped with this project and joined and helped us out. I also like to acknowledge the Gene Conservation Lab and USGS. Without them, they did all the heavy lifting. Collecting the samples out in the field and getting samples from darted moose are really easy. But doing all the lab analysis and being precise and making sure everything's labeled correctly and run and getting individual IDs for all these moose. They did all the heavy lifting for us, and we really appreciate all their help.